We're analyzing our data in RStudio here of our study of mobile text entry with 24 participants, half of whom used the iPhone and half used the Galaxy, and all of whom were standing, sitting, and walking in those three different postures, entering text entry phrases. We're keeping all of our phrases, so we have a large data table with 1,440 data points for both words per minute and error rate. We've just finished a linear mixed model for words per minute, and now we're going to use a generalized linear mixed model, which allows us to model the Poisson nature of error rate. It's a count variable if we think of it in terms of errors per 100, say, trials. And that gives us an integer, a positive integer. We need non-negative integers for Poisson regression. And so we'll use the generalized linear mixed model to carry that out. So let's go ahead and begin here. So we will turn error rate into a new column called errors, because error rate is a decimal and we need it to be a non-negative integer, so we'll just multiply it by 100. Pretty simple data transformation there. And then we'll just verify our table again. So we can see now a rightmost column called errors, which has non-negative integers in it. And we can now summarize again over our table. Different columns here, and we can see a new summary for the errors column. Looks like the mean errors were about 3.3 or 3.4 errors per text entry phrase. Okay, so let's explore the new errors column as we've explored data in the past. Here we can see results for each of the keyboard posture combinations in terms of their mean and median, and here we can see the same for mean and standard deviation. We can also explore, as we've done, the histograms for this errors data. So here we see the errors for the iPhone sitting condition. Here is standing. Here's the iPhone errors while walking. We can see the shapes of this data are very Poisson looking, which count data often is. Galaxy sitting, Galaxy standing, and Galaxy walking. A box plot helps us see a bit more here, and we can see that the sitting situation seems to have perhaps the lowest errors for both phones, standing as well, and those seem very similar. And then while walking, we have more errors, which we'd expect, but also the Galaxy seems to have even more errors than the iPhone. That's suggestive of an interaction, and we'll recognize, I think, the interaction plot from before, where we see similar sitting and standing, but different errors in the walking condition. And so that's clearly going to result in an interaction. Okay, so let's verify that the new errors we've got here are, in fact, Poisson distributed. Because we do have the data for every single trial, remember, not just summarizing over 20 trials at a time. So we will fit to the iPhone sitting condition, the Poisson, and then we'll progress through the other ones as well. And we'll add the goodness of fit test and just verify that we are not significantly different or detectably different from a Poisson distribution. I'll remind you that these tests are just guidelines. We have a lot of data here, and so it should be easy actually to be different, significantly different from an ideal Poisson distribution. So if we're not, that would give us fairly good confidence that we are, in fact, Poisson distributed. Here we have a non-significant chi-squared result for the iPhone when sitting. And let's do the same for standing, and we can see 0.10. Let's do the same for the iPhone while walking. We see 0.42. So far, so good. Let's do the Galaxy when sitting. We see 0.78. The Galaxy when standing was 0.57. And lastly, the Galaxy when walking is 0.058. Well, this one was the closest to a non-Poisson distribution. And so, but we're still clear of statistical significance. Which, especially in light of all the other tests, gives us enough confidence to proceed. If we want to re-graph the histogram of the Galaxy data when walking, we can do that back up here again and see that this one is almost quasi-normal, so perhaps that's why we have a closer to significance result. Okay, so let's proceed now with some confidence that Poisson regression with a generalized linear mixed model makes sense. So we'll load in the libraries we need for the generalized linear mixed effects model we're going to do. And we'll set the contrast as we've done because we're going to use the capital A ANOVA call. And then we're going to run our main generalized linear mixed model or mixed effects model on the errors column we created. We do that with the glimmer function, and we can see our model here. So errors is our Y response, our outcome. Keyboard by posture are factors. Trial is nested within keyboard and posture, just as we've done before. And subject is our random effect, which allows us to correlate across rows in our table and handle the fact that posture is a within subjects effect. We see that we're running it with a Poisson distribution. And there's also this parameter, the NAGQ, which I've set to 0. I have a little note here that the default for this value is 1, but the analysis takes quite a lot longer to complete. And so setting it to 0 actually turns out to give almost exactly the same results, but completes much more quickly. So let's go ahead and we will fit that model and report the ANOVA, and we see, because we're doing Poisson regression, a chi-squared outcome. And we see, in fact, let's move back to our plot here. We see that we have a significant main effect of keyboard, significant main effect of posture, and a significant keyboard by posture interaction, all of which we would intuit from the graph. We don't care much about trial, and it's not significant anyway. So we can then be justified in moving into post hoc pairwise comparisons. And so I put here the code to execute our graph for us, which we've already got up just for convenience. And then we can move into doing all the pairwise comparisons between levels of keyboard and posture that we might want. Again, don't go on a fishing expedition, but if you have particular pairwise comparisons in mind, you can run all of them like we've done here, or just run those specific ones and always adjust for multiple comparisons, however many you do. And we can see that as the main ones we'd be interested in are how the keyboards compare in the different postures. We can see that there's no real difference in the sitting posture between the keyboards. In the standing posture, let's highlight that line. That would be the, let's see, iPhone stand and Galaxy stand. So that's this one. And we also see there's no real difference there either. And then in the walking posture, the Galaxy walk and iPhone walk is statistically significantly different. And we did adjust these with the multiple corrections adjustment called the home sequential Bonferroni procedure, so we can feel a little bit better about having run so many pairwise comparisons. So that is our generalized linear mixed model, allowing us to do Poisson regression on a within subjects and between subjects mixed design with keyboard and posture. We nested trial, and we use subject as a random effect. And we've seen that our results are corroborated by our prior analysis of the same data, but where we only had 72 rows of data because we were averaging over all 20 trials in every condition. Let's go now to our table of analyses and see where this has finally brought us by the end of our R code file here. Here we are at our table of analyses, and we've reached the last row, where we've highlighted linear mixed models and generalized linear mixed models. We used linear mixed models to analyze words per minute data, or text entry speed data, from our mobile text entry study of 2 keyboards and 3 postures. We had a between subjects factor of keyboard and within subjects factor of posture, so we had a repeated measures ANOVA situation, but rather than doing a regular fixed effects ANOVA like we've done in the past, we did a mixed effects model, a linear mixed effects model, which allowed us to model our fixed effects, which are our factors of interest, keyboard and posture, and our random effect of subject, which allows us to handle within subjects designs. We also did a generalized linear mixed model, which allowed us to model response distributions that were different from normal, in this case a Poisson distributed response, which were the errors made during the text entry study.